Okay, what is the unit circle? So I'm going to talk about the entirety of the unit circle. Um, One way of teaching and presenting this is to teach it quadrant by quadrant over time so that the entirety of the unit circle gets kind of discussed in pieces. Here I'm going to talk about the unit circle, though, in its entirety and how it relates to the reference angles that we just worked on in this section. Okay, so remember that like the unit circle is 360 degrees. Okay, so here we've got a circle and one rotation around the circle is 360 degrees. And remember that 360 is a highly composite number with 24 divisors, which means that 360 can be subdivided without creating decimal values. A few of these 24 divisors are considered special angles. And some of those special angles in degrees are 0, 30, 45, 60, and 90. And in radians, it's 0, pi over 6, pi over 4, pi over 3, and pi over 2. So 2, 3, 4, and 6 being those special divisors of 360. A unit circle has a radius equal to 1. Okay, this is a really important property of the unit circle. So, it starts here at 0, and the distance from 0 out to the edge of the unit circle right here is 1, has a radius of 1. So you can see at this point, the coordinate is 1 on the x-axis, 0 on the y. That's the coordinate of this point right here. And as we go up from 0 and we arrive at this point, the coordinate of that point on the unit circle is 0 on the x, 1 on the y. So it's gone 1 up. And if we go from 0 and we go to the left, we go to negative values of x. To this point on the unit circle, the coordinate of that point is negative 1 on the x, 0 on the y. So now x is negative because we're on the negative side of the x-axis. And if we go down from 0 and we go downwards, okay, these are negative values of y down here, and the coordinate of this point on the unit circle is 0 on the x, negative 1 on the y. All right, so the coordinates, at these, I would say, kind of cardinal directions here, this way, that way, up and down, these coordinates on the unit circle all have 0 or 1 in them because the unit circle has a radius of 1. All right, and this unit circle is subdivided by special angles in both degrees and radians. So those special angles are what you see here. So each of these lines kind of radiating out from the origin, radiating out from 0, these are all terminal sides for each of these different angles. Okay. And that's what we've been looking at. We've been looking at angles of interest and their terminal sides. And where do those terminal sides reside? Right? Is the terminal side here in quadrant 1? Is it here, here, or here? That's in quadrant 1. Is it in quadrant 2? So is the angle going from here that way, or that way? Likewise, is it in quadrant 3? So is the angle going from the initial side here, going all the way around to here, here, or here? And therefore, it's in quadrant 3. Or starting from this initial side, is the angle of interest going all the way around and terminating here, here, or here in quadrant 4? Now you'll see at the ends of each of these terminal sides, we have a coordinate, an XY coordinate. Okay, so we have an X and Y coordinate there, X and Y coordinate there, and X and Y coordinate there. And what is it that you notice about these X and Y coordinates? Well, there are 3 fractions that continue to occur. It's 1/2, square root of 3 over 2, and square root of 2 over 2. Those are the only 3 fractions you have to remember for the entire unit circle. Okay, but where do these occur? Where do those fractions occur? In the unit circle. Well, let's take a look. So you remember in a previous example, I showed one angle was 60 degrees, right? 60 degrees. And the coordinates at this point on the unit circle was 1/2 square root of 3 over 2. And then we had a second angle, which was 120 degrees, and it too had 1/2 square root of 3 over 2. So the x value was 1/2, and the y value was square root of 3 over 2. And the reason why these had the same fractions in the same place, in x and y, is because they had the same reference angle, right? So here's the reference angle for 60. And the reference angle for 120 was this angle here, and that too was 60. Well, look at the coordinates for this angle here. It's 1/2 square root of 3 over 2. The same 1/2 and square root of 3 over 2 as we had up here, here, and here. And why is that? That's because the reference angle between that terminal side and the x-axis is also 60 degrees. And if we go one step more, let me go ahead and change this to, change it to green. That should be fine. So if we come along here on the initial side and we come down, you can see we have an x value of 1/2 and a y value of square root of 3 over 2. And again, that's because the reference angle is also 60 degrees. So every angle of interest with the same reference angle is going to have the same fractions in x and y. They're all going to be the same. The one thing that changes, though, is just where each of these points are respective to the x and the y-axis, right? In quadrant 1, x is positive and y is positive. So each of these fractions will be positive. Over here in quadrant 2, the x value will be negative. So you can expect a negative fraction here, but the y value will be positive. So you'll expect that to be positive. Down here, we're dealing with a negative x value. So our x value here is going to be negative, and we're dealing with negative y values. So the y value here will be negative. And coincidentally, the same in quadrant 4. In quadrant 4, the x values are positive, but the y values are negative. So even though the fractions remain the same, they just differ by being positive or negative. All right. So let me kind of get rid of all of this to maybe try and keep everything as simple as I can make it. Because you can always reverse the video and rewatch that part, right? Okay. Um, so let's look at some more angles that have the same reference angle. So if we look at 30 degrees, okay, that's a reference angle of 30. Now notice that the 1/2 square root of 3 over 2 values we had are just flipped. Instead of 1/2 being the x value, now 1/2 is the y value. And instead of the square root of 3 over 2 being the y value, square root of 3 over 2 is now the x value. And look at the other angles of interest with reference angles of 30 degrees. This one, and this one. They have square root of 3 over 2, 1/2, square root of 3 over 2, 1/2, square root of 3 over 2, 1/2, square root of 3 over 2, 1/2. Just differing by positive or negative based on where the locations of each of the points on the unit circle are. Quadrant 1, quadrant 2, 3, or 4. Okay. So that's why learning reference angles was so important, is it tells you, it informs you on the symmetry of the unit circle itself. And last but not least, I mentioned that the unit circle has these fractions in it. So where is the square root of 2 over 2? Well, square root of 2 over 2 is the x and y coordinate for reference angles of 45 degrees. Okay, so you'll see that one, this one, this one, and this one. They have square root of 2 over 2, square root of 2 over 2, square root of 2 over 2. Now, kind of where square root of 2 over 2, square root of 3 over 2 and 1/2, yeah, let me go ahead and explain that. So why are those values where they are? So let's look at that next. So you'll notice that, let's start with this one, which is 60 degrees. So why is 1/2 the x value? Well, that's the coordinate at this point. So if we just trace down to the x-axis from that point, remember, it's going from 0 here to 1 out here. Well, wouldn't halfway between 0 and 1, isn't that 1/2? So that's where the coordinate 1/2 is. If you go from this point and you drop down, it hits the x-axis at positive 1/2. And if you take this point and you go over, okay, it crosses the y-axis at square root of 3 over 2. Now watch what happens when we look at the other angle of interest that also has those same fractions, but those fractions are now reversed. Well, look what happens if we go to the y-axis. Where is it splitting the y-axis? Well, it starts at 0, it goes up to 1, and you can see that where the y-coordinate is for this point, when you come over, it's hitting the y-axis at exactly halfway between 0 and 1. So that's where y being 1/2 comes from. And then the x coordinate is the square root of 3 over 2. So if you ever need to remember, where does this 1/2 go? Just think of where the point is. And if you were to come down or come over, does it hit the x-axis or the y-axis at 1/2? That'll tell you where the 1/2 goes. Um, and in terms of this square root of 2 over 2, for the x and y coordinate at this point, just the thing to notice here is that these two are exactly the same. That's because if you drop down and you drop over, where it hits the x and the y-axis is going to be the same value. And it does that because of the nature of this angle. It's 45 degrees there, and it's 45 degrees there. Making that, yeah. Okay. So I think in general, okay, that's almost everything. Let me mention one more point in that, this is the initial side. And as you go around, right, you're going from quadrant 1 to 2 to 3 to 4. And so the measurement of angles starts here. So 0 degrees, 30 plus 30 plus 45 plus 60 plus 90. So it's going in this counterclockwise direction, which means we're dealing with positive angles here. So positive 120, positive 135, positive 150, positive 180, and so on as you go all the way around. So the unit circle is drawn and designed and meant to be used with a counterclockwise rotation. And I think the last thing to mention here is radians. Okay. So, you start here at 0 radians, and we already know that by the time we go halfway around the circle, that's 180 degrees or pi radians. So why is this value up here pi over 2? Well, if this is our angle of interest, that's pi over 2 radians to get to there. Well, how many of those angles of interest does it take to get you all the way to pi? It takes 1, 2 of them. That's why you have a denominator of 2. It takes 2 pi over 2s to get you to pi. Okay, again, here's pi, half a rotation. What about pi over 3? How many pi over 3s does it take? Well, here's 1 pi over 3. If we went to this point, that is 2 pi's over 3. And then our final one is 3 pi over 3. So we had 1 pi over 3, 2 pi's over 3, and here's our third pi over 3. The 3's cancel, leaving you with just pi. And we can play the same trick with pi over 6. Get a different color here. See if that one works. Okay, so here at pi over 6, pretty dark. Um, why is the denominator 6? Because there are 6 of these slices. So there's 1, here's 2, here's 3, here's 4, here's 5, and here's the 6th one. So it takes 6 pi over 6s to get half of rotation around. The 6's cancel and leave you with just pi. So that's where the denominator for each of these radian measures comes from. It's how many times you're having to subdivide pi by. Okay. The reason why I designed this unit circle this way is you'll notice this shape here, which is the intersection between the terminal side and the unit circle. I marked that with a hexagon. It's a hexagon because a hexagon has 6 sides. I used a square to represent where the terminal side and the unit circle intersect. And a square has 4 sides. And here at this terminal side, where the terminal side hits the unit circle, I used a point, or I'm sorry, I used a point that's a triangle, and a triangle has 3 sides. So I tried to give you a visual to also help you see where those different denominators should go for the measurement of radians. Okay, and finally, maybe the last pattern I would mention here is that in quadrant 2, you'll notice that the numerator is 1 less than the denominator. See that? 2 is 1 less than 3. 3 is 1 less than 4. 5 is 1 less than 6. So in the second quadrant, the numerator is 1 less than the denominator. Whereas over here in quadrant 3, it's the opposite. In quadrant 3, the numerator is 1 more than the denominator. Numerator, 1 more than the denominator. Numerator, 1 more than the denominator. Numerator, 1 more than the denominator. And in terms of the fourth quadrant, at this point, you just need to remember 5, 7, and 11. So those 3 prime numbers, 5, 7, and 11. Okay. So I think that gives enough of a full description here of the unit circle. We'll go further into more of the geometry of this when we talk about trigonometry functions. Okay, but since we haven't started talking about those yet, this just gives an overall description of the patterns and the parameters here of this unit circle. Okay, let me know if you have any questions.